Hello, and welcome to today's Saratech Enablement session. My name is Andrea Hall, and I'll be your host today. I am the Customer Relationship Manager here at Saratech, so if you've ever called our support line, I'm sure we've spoken. Presenting today, we have Chip Fricke, who is with Siemens, and he's going to be talking to you about what's new in Femap 2019. And with that, I'm going to pass it over to Chip.
Yes, I guess good morning or good afternoon, depending upon where you're located. Again, my name is Chip Fricke. I'm an application engineer within the Femap product development group. And I've actually been now using Femap now going on 22 years. So last fall we released Femap 12. We did a 12.01 release in December. We have released Femap 2019.1, and then in the end of July, we released the 2019.1 Maintenance Pack 1. We're in the process of wrapping up coding on the V20.1. In fact, that'll be completed this week, and then we'll go into about a 2-week period of internal alpha and then beta, and the plan is to release V20.1 the end of October. Now there has been a bit of a change in our release cycle, really to kind of align ourselves with the rest of the digital industry softwares group. By the way, we are now referred to as Siemens Digital Industry Software rather than Siemens PLM Software. I guess that became official on Tuesday. So we're now going to do a new feature release every 6 months, and generally we'll do one. There'll probably be one maintenance release about 3 months after that release. So again, V20.1 will be released the end of October. I'm not going to talk any details on what's going on in there, but I want to concentrate on 2019.1. So we put a lot of new functionality, some new user interface things in there, visualization, more on pre-processing, meshing, and we'll talk more about that, solvers, post-processing, and I'm not really going to talk about any future projects right now. One of the things we added in 2019.1 is the ability to show thumbnails and tooltips on the model files. So if you have your Windows Explorer set to show icons, you can hover the mouse over it, hover the mouse over the preview of the modfem file, and then the little tooltip will pop up that'll tell you information about the last save date and the number of nodes and elements and result sets in the model. Now, this is not automatic. There is a BAT file in the Femap installation folder that you have to run as administrator from the Windows DOS or prompt. We did one of the big things to the dialog or the user interface was updated the entity selection dialog box. So we've changed the reset button now. Instead of hitting reset, there's an icon button. Basically, the little X marks the spot button. And then there's a new option called Select Visible. So this allows you to select all entities of the type that are visible. Now, if you're zoomed in, and say something is outside of what's zoomed in, those are still selected. So basically, any entity that's not hidden by a setting for visibility, such as entity type and individual entity elements, et cetera, will be automatically selected. And they also cannot be hidden by the Draw Erase toolbar, and it's also affected by group and layer settings. But this is a really nice way, rather than having to zoom in and then draw a box around everything, you could just hit the Select Visible icon. Also, with this Select Visible, with the pick menu, you could go to the pick menu and then you could go say Select Visible Only, and then say select by color, by model data value, by output. There's the connected elements, and then add all connected elements that are visibles. So you can just pick one element and then hit add all connected elements. So this is very, very handy now for picking without having to go to layers or groups or even the display toolbar. Another thing we've done is we've increased the size of the fields in there. So now we're preparing for the supportive IDs above the 99,999,999, which we call large IDs. We're expecting in the future the models are going to get larger and larger. And some companies would like to use larger ID fields. So we increased the width of those as well. Another thing we've done now in not only in the UI and visualization is we've added some new tabs to the libraries. So before, when you wanted to load something from a library, you had to hit the load button, select the library, and then it would show you a list. Now what we've done is added the ability to have not only the Femap standard libraries or what you've set as a library location as a preference, you now have a personal set of libraries, and those will be in you could set that in the preferences dialog box. There's something called shared, which you can set in preferences dialog box, and then there's the standard libraries. One thing to note about the standard libraries now, those are only read-only. So if you have libraries that you need to make changes on, you need to move those to another location because we've set those, again, the standard Femap material libraries are read-only. The personal by default is going to go in your Windows user location. If you have multiple libraries in a location, now there's a drop-down menu. Rather than having to go to the Windows Explorer to pick it, you can now pick the library from the drop-down menu at that location. And again, the default path location is in your username, app data, local Femap 2019.1. In fact, in the past, things such as your user interface and all of that information was stored in the registry. It still is, but a lot of that information now is now stored in this app local data. Then you can also change if you want to change the path, there is an icon button on the right of the path field to change that. Okay, you can now do things such as copy text from the analysis monitor. We can now renumber views. In the past, you had to actually go through an API to renumber a view. You could copy and renumber views in the model info tree. And then you also have the ability to renumber charts and chart data series. One of the new things we've added in preprocessing is the ability to maintain loads, boundary conditions, and connection regions when doing geometry splitting in the meshing toolbox. So this little picture here shows you some loads on a bunch of surfaces. You can see you've got like a force of 125 on one surface, 290.5 on another, and some splitting has gone on. Basically, a couple point-to-edge commands have gone on, and you notice that those loads get propagated to those new split surfaces. So you don't have to go back and edit those loads any longer, the location of the loads. And again, it's not only loads, boundary conditions, but connection regions as well. And again, this works if you do this editing in the meshing toolbox. We're also doing some things called solid data tracking, such as color, layer, attributes, loads, constraints, and regions. So basically what you can do if you do a solid slice now, in this example, all of the things such as the regions, you can see this, we kind of split it down the model of this bracket, and then there's like 3 probably pins or something in that bracket. You notice that all of the colors and everything else are maintained as well. So the color of the bracket, we just split the bracket, and then the region got propagated as well. We've added some new force abilities. So before you could put force or bearing forces on curves and torques, bearing forces and torques on surfaces. Now we've added the ability to do the same thing on curves for both the bearing force and the torque. In the past, you pretty much had to use either a function, a variable, or a data surface. We've added some new abilities to do pointed node projection. You notice now you can set a direction which is radial around an axis or radial around a point. So for example, if I do an axis, it's basically going to project it radial along that axis, and radial about a point is going to be more like a spherical projection. So you have those two options as well. Some new mesh sweeping. We've improved the sweep element and element face. So what you do is you first select your elements to sweep, and then the edges of the planar solid elements to sweep along. And then what you could do is you could define the direction with a single edge pick rather than having to define a vector. And then it sweeps until the end is reached or connecting back on itself. So this also allows you to do a stop mode. So for example, if I really wanted only to go in this example here, I'm really only going to this point here. That's the stop node, and it'll allow you to stop that sweep even though this curve continues along. And basically the mesh is morphing to match the existing mesh edges. So it's going to twist or change direction based upon the curve. So here's an example of the mesh, how this works. So you start the element face or the elements, and then there's we're specifying a 180-degree path, and then it's going to sweep it. So you notice this is not basically a cylindrical type thing. It's looking at the outside edges of that, and it's going to maintain that angle as well. Here's another example. So we want to sweep element edges onto a plate. So you pick the element edge you want to sweep, and then the path, and then it'll sweep that around that in there. It'll also allow you to do things like sweep beams into plates. So this is a really nice new feature, kind of a way of doing mesh morphing within Femap. We've added some new abilities to do the hex to tet pyramid transitions. So now you could basically, let's say for an example, these are 3 different solids, or this could be, you could define a pyramid location. So this is a lot easier to transition from a hex mesh to a tetrahedral mesh by doing this combined tet pyramid mesh. And again, you can tell it you specify the pyramid locations where you want pyramid elements to be. So for an example, in this case, I want the pyramid elements to be along the ends of the hex element mesh, and then it'll automatically do that transition with the pyramids to the tetrahedrons. And it'll also match either adjacent parabolic elements and or linear elements. So in this case, I'm getting 10 noded tets, but I'm matching it with pyramids. So the defaults are a linear brick wedge mesh and to a parabolic tetrahedral mesh transition. So the tetrahedrals are parabolic with the midside nodes dropped for the brick connection. In other words, it's going to split it's not going to put a pyramid at the midside node. And then the pyramid becomes parabolic. And then so basically, again, you can define on interior solids to further reduce the total degrees of freedom. So I could do basically this type of transition with a hex mesh to pyramids and then back out to a tetrahedral mesh. So you got several options for doing this type of transition. You can also do things like you can connect to any surface, mesh with quad elements, and then transition into tetrahedrons. So basically go from outside in. We also could do rather than doing that we were showing you before was doing the mesh solid tetrahedral command. Now you can also do what you can do is modify update elements and connect linear and parabolic elements with pyramids. So basically this example is showing taking a tetrahedral element, a bunch of tetrahedral elements, and connecting it to that brick with these pyramids. So you see you've got the connection methods, you got the ability to select by elements, surfaces, and or solids. You notice you got the option to do all three. You have options to do update. It says add midside nodes to linear edges or remove midside nodes from parabolic edges. You can also do a merge coincident nodes before the update. And then what you could automatically do is generate a group for the updated elements and the disconnected midside nodes. So this is, again, the modify, update elements, connect linear and parabolic element command. This also works with a shell element meshes and mixed beam shell, solid, and element meshes. So what it does is it'll make a small patch of elements parabolic and then connect the linear shell elements. We can also do some new mesh extrude operations. If you look right here, you can now do an extrude normal to surface. So here I'm doing basically, I've got kind of a spherical plate mesh, and I want to extrude that now to the basically this pair of cylindrical surfaces. So now what you would do is you tell it along normals to surfaces, tell it the property, the elements along length, it'll automatically basically extrude those based upon that selection of how you set the normals. We can also now do an extrude in two directions at once. So for example, if I want to do what I basically am starting from the mid of this mesh, or in this case, this plate mesh you see here, but I want to extrude it both in and out. So it's think of it kind of equivalent to the command where you thicken a solid. This is kind of like thickening a shell mesh in both directions. Okay, the 2019.1 is including the Simcenter Nastran 2019.1 release. The 2020.1 release will include the 2019.2 release. We have done some big improvements. So we've resolved multiple subcase responses in the design optimization solution 200. We've also done a lot of work in solution 401. So we're now allowing the bolt preload that allows the 1D bolt elements. Previously, we only could have solid preload bolts, bolt elements. We're also supporting the PCOMP and PCOMP-G for solution 401. We've added transient dynamic response subcases for 401. And then we've also done some contact improvements as well. I'm not sure if you've done much with the other thing we've done, what contact is in 401 and 402, which is the multi-step nonlinear. When you define contact, you have the option as part of the boundary conditions to specify a set of linear contact or contact connections and then a set of glued connections. So we've also supported that UI. We started actually doing that, with 2019.1. Also, there's been some new performance enhancements to Simcenter Nastran for RD modes. There's the SMP parallel has added an element matrix assembly module. And then there's some new improvements to the frequency response. So there's new subcase types. At 401, 402, there's nonlinear dynamics. We've also added linearized buckling. And then we have arc length methods and statics as well. So I don't know if any of you are using the multi-step nonlinear. The nice thing about this is you could do a lot of pre-stiffening. For example, if you want to do pre-stiffened modal, you could do that, or pre-stiffened buckling. And then you can also do multiple step cases. And again, this could be sequential or non-sequential subcases as well. So in this case, what we're showing is a non-linearized pre-stiffening. And then what we're doing is we're looking at the transient response of that pre-stiffened model in subcase 2. Just for your information, there is a multi-step nonlinear class being developed. We're going to be teaching that internally in October. And then once that goes through there and a few modifications, that'll become a class available to customers. For the design optimization or solution 200, we've added frequency response analysis, and it's very similar to setting up your static and modal design optimization runs. In Femap, we're now supporting the Nastran material coordinate system on elements. So basically, you can have one property but multiple orientations. In the past, you actually had to have multiple properties. So there's a new command called modify update elements solid material CSIS, and then you have the multiple ways to define that. And so what this will do is this will write out the Nastran MAT CID card, or basically the coordinate system ID for each element that you assign material orientation. We've set up new stat sub for buckling subcases. So now you could do more buckling instead of doing an individual analysis set for each buckling analysis. Now you can set up multiple buckling in a single analysis set through the stat sub. We've added some new capabilities to the ANSYS translator. It's the ability to do 2D element edge pressure, pressure on solid element faces and shell element edges, added new beam preloading, solid preloads, and then these are written as the ANSYS S-load card. And we've done some new support for the ANSYS random vibration. We continue to make new additions. Basically, I would say probably about 3-4 years ago was the old ANSYS Prep 7 type format. Now we're actually, we're compliant with the new ANSYS deck formats. We've added some new capabilities for Abacus. We're now adding the ability to add conductance and radiation gap options. So in this case, you could do both, either or, and then you can define a view factor as a function versus or a conductance versus clearance and temperature, or you could do a emissivity function versus the gap clearance. If you're doing any aeroelasticity, we're still continuing to enhance that. And now we can display aero mesh displacement results from a flutter analysis. The way you do that was basically you need to write out your results to the FO6 file. And then when you read in the FO6 file, you can display the deformed aero mesh. Contour plots, you now do partial results. Basically, what this will do is you have 3 options. You can show the elements with no results, which is like the old default that always did that before. You could hide the elements with no results, or you could say contour with 0. So this is basically the old one. This upper left one is showing the elements with no results. This one is hiding all the elements with no results. And then the third one is basically contour elements with no results as a value of 0. So that's a new option in post-processing. We've We've consolidated the listed format output commands. Before there was like 3 or 4 different commands for doing a list output. So now you could there's a new command called list output formatted. And then also so this is basically writing this to a file. You could there's also the command to be able to do list output formatted to the data table as well. Okay, what we've done in MP1, so maintenance pack 1, is we could automatically generate some cases in Femap using the multi-set capability. So basically, this is identical to doing synthetic nastran buckling subcases that we did in previous versions. Abacus, we've done some new read support for distribution and distribution table entities, as well as the support for the orientation and angle variables. And then we've added read support for coupling and distributing entities. Okay, so that wraps up my presentation on what's new in Femap 2019.1. I did want to make a point. We're in the process, for those people that subscribe to the Femap community forum, we're doing some revisions to the platform that it's being posted on. So right now it's basically in a read-only format. It's been that way for a little over a week. I'm not quite sure on the date of when it's going to be fully re-implemented, but just so people are aware, we're not dropping the forum. It's just being rehosted on a different platform.
Okay. Okay, good. That's good information. We actually did have a question. Someone would like to know are you able to share these slides or not?
I think if people just email me, we don't want to post these. I mean, people will be able to see the YouTube, but we don't necessarily want to have these posted on a public server someplace. Or
right.
I guess we'll have to see what we could do. I think what we could probably do is do a PDF version, and once the forum is back implemented, we could probably just post those on that.
Post them on there. Okay. And Chip, will you share your email address for people who might want the slides?
Okay, hold on a second here. Let me just put in a new slide here.
Perfect. And while you're doing that, just a couple of last minute announcements. Our next session is going to be with Dave Wingrave, also from Siemens. He's going to be talking about NX, PMI model-based definition. So make sure that you share that, and you can also register for that on our website. And thanks for sharing your email address there. And I hope you all have a wonderful day, and we hope to see you again at a future session. Thanks, Chip.
Yeah, you're welcome.
Okay, bye-bye.